So these are some trig problems where we're going to try to find horizontal asymptotes. So for this one, we have to think about the limit as the inside of this approaches infinity and negative infinity. So I'm going to take the limit as x approaches infinity of 2x minus 1. Now the highest degree in the denominator is x squared, so I'm going to divide each piece by x squared, just so I have to rewrite it several times. Over x squared plus 3 over x squared. So I'm taking the limit again of the inside as the inside approaches infinity. And seeing what happens as x approaches infinity on the inside. So if we simplify this down, we will now get the limit as x approaches infinity of 2 over x minus 1 over x squared over 1 plus 3 over x squared. And when you do that, now if you plug in infinity, you get 0 minus 0 over 1 plus 0, which looks like we get 0. So what that's saying is, as we go to infinity, cosine, all right, of basically, let me restate that. As we go to infinity, what's inside, remember what's inside is approaching 0. So really what we're saying is we're saying cosine 0 is what it's approaching. Because what's inside, again, is approaching 0. So cosine of 0, what is cosine of 0 equal to? Again, if you think about the unit circle, right here is 0. What's the cosine? It's 1. So the answer to this is y equals 1 would be your horizontal asymptote. Because that is what it's approaching as what's inside approaches infinity, which equals closer to 0. And then when you plug that 0 in, you get y equals 1 as your horizontal asymptote. You could go back and put negative infinity in, but it'd be the same answer. So let's focus on g of x here. All right, so this one, well, let's take the limit as x approaches infinity here. If we do that, we get cosine of 4 times infinity over infinity. Now this is a weird one because, okay, so this is infinity on the bottom, but what is this? Well, if we think about it, if we think back to the unit circle, okay, think of the unit circle again. As we go around this unit circle, all right, the cosine values, do you know that the cosine values, as you go on over and over, isn't it the farthest to the right is 1 and the farthest to the left is negative 1? So if you think about it, don't we, on a unit circle, I mean the height right here, remember it's how far left and right is cosine, you don't care about the height. So really, cosine values fluctuate between negative 1 and 1. So the y values of cosine are going to be between negative 1 and 1. Those are where the y values are of cosine, the outputs. Actually, y would be g of x. But they're between negative 1 and 1. So 4 to infinity, well, it's going to be fluctuating between negative 1 and 1. Okay? Because you're plugging in numbers, and the numbers just keep wrapping around the circle. And so isn't this top number basically going to be somewhere between negative 1 and 1? So what you really have here, if you think of it, is a constant over infinity. And what is a constant over infinity approach? Well, a constant over infinity, you should know, is approaching 0. So what would be my horizontal asymptote is y equals 0. That would be my horizontal asymptote because I'd be getting a constant somewhere between negative 1 and 1 over infinity, which is 0. So there's my horizontal asymptote. Both of these are a little bit trickier, a little bit more unique.